everyone. So in this segment, we'll be talking about BBS. So what is this BBS? BBS is basically a bar bending schedule. So these bars are used as reinforcements in RCC. So in order to provide all the tensile requirements that is required by a concrete. As you all know, RCC, it is reinforced cement concrete. So over here, what exactly happens is the concrete will be providing most of the compression strength, and the steel that is used provides all the tensile requirements. So this is the very basic ones which we know about RCC. So bar bending schedule in simple terms, what does it mean is what is the total amount of steel that is required for the construction of the building structure or the project. That is BBS in very, very simple terms. Now, say for example, a contractor, he will be having hundreds of questions regarding how much of steel is required for a G+10 building, or how much of steel should I be ordering? All of these are the common set of questions that will be having from the contractor. So these simple questions will be answered at one point solution, that is with the BBS. So BBS gives the total amount of steel that is required for the construction. That is where BBS actually comes into the picture. Now, these bar bending schedule, they are organized in each of the structural units. So in each of the structural units, like I'll just move forward. See, these are with the basic things, coming with the length, coming with the weight and the density of all of these bars. So not only amongst these things about the bars, we'll also have to consider in which region, in which structural unit this particular bar is actually been used. So now maybe structural steel with respect to beam, only for the beam how much of steel is required, only for the column or only for the slab how much quantity of steel is required is what BBS actually gives you completely. So there, that is what I meant by various structural units when I mentioned previously. So now this BBS actually gives a detailed list of the things that we will be considering in bar bending schedule. So starting with the bar location, like I mentioned, where exactly this particular bar is going to be used, whether it is for the column or whether it is for beam or whether it is for the footing that you are actually looking forward. And then we have bar markings. That is where exactly now, for example, when there is the stirrups that is used for the columns. So where the bar bending has to be made. So their bar markings is where it comes into the picture. So bar marking is one of the details that will be mentioned in BBS. And then moving forward, we do have about the bar sizes. What is the diameter of the bar? Starting from 8 mm till 16 mm. There are many sizes of the bars depending on the kind of load that will be acting on that particular structural unit. And then moving forward, we have with respect to the quantity. How many number of bars is required? It is a circular column. Then there might be main bars that will be varying with respect to 6 to 8. When if it is a square bar with the sizes of 30 centimeters, then for about 4 main bars would be required. That way the number of bars that is required will be mentioned. Then coming to cutting of bars. So after marking the bars, say for example, now you have a feet or you have a whole column of about 15 meters. Now, like you're seeing over here, one of the basic things of bar, it is that the whole length of the bar, it is very standard and it is for 12 meters. So now the column is for 15 meters. So then what happens in future, it is like extra 3-meter bar, you will have to overlap with it. What exactly an overlapping is, I'll just be teaching you in the next slide. And that is like one of the standards with respect to the bar. And then we have what type of bend. So based on the angle, should it be a right angle bend or should it be an acute angle bend? Sometimes it would require for a 135-degree bend, or it might require for a 35-degree bend. So based on the whole design unit, that is where the type of the bend comes to the picture. And definitely the bend and the shape, just in case if it is a triangular one or with a 60-degree angle, you will be making it up. And then if it is a circular, definitely that particular angle of bend will change. So these various things is what you will have to be considering. And apart from that, we've got weight of the bar. So weight of the bar, it is shown over here as d square by 162. All of these things, definitely in your engineering, you would have derived this particular formula. So here I won't be completely getting into the details of it. So d here is nothing but the complete diameter, that is the size of the bar that you have been using. Definitely that will be giving you the whole weight of that particular bar. And another main important thing is the density. So density, this is also very standard. These are the three standard things for bar that everybody must consider. That is 12 meters of length, having d square by 162 as determining the weight of the particular bar, and then moving forward, taking the standard of bar density of 7,850 kg per meter cube that has been there. Now coming to what is the preparation of BBS. So before a bar bending schedule has been prepared, these are the three basic main things that you will actually have to know. They are the technical terms that you will know with respect to bar bending. Firstly, coming to hook length. Hook length is nothing but what is the whole length of the bar where it has been bent. Using this cursor, I will just take you forward. Now you can see this is one of the bars. Now there is a whole bend that is made over here. So the length, you will be dividing it as, you can see point number 1, 2, 3, and 4. So all of these things put together, you will have the whole length of this particular bar based on the bend as well. So that is called as the hook length. Majority of the time, you will see this in stirrups. So I know you will be thinking what a stirrup is. So over here, see, this is the top angle of the bar structure, okay? These 4 dots that you can see over here, they are basically the main bars. That is with the bigger diameter, the one which actually takes the load directly. Now, in order to keep these main bars intact, for it to not to bend, now this is the whole bar that is actually acting, and here the load is what that has been applied. So this bend shouldn't be happening. For that reason, to keep these main bars intact, stirrups actually comes into the picture. So over here, you can see these stirrup. The whole boundary line that you can see over here is the stirrup. That is called as, because it has multiple bends. See, now we have mentioned 5. I'll show you how. This is the starting of the bar. Okay, so there is one bend. Definitely this is 2, 3, 4. And again, this whole bar is getting bent again at the starting point when it started bending. That's why the whole bar, if you consider, there are 5 sets of bend in this particular image. So that is why it is mentioned as 5 bends, and that is going to be the complete hook length of that particular rebar. Next, you have with respect to the bend lengths. So over here, this is one of the corner bends that you saw here, because it has a complete 90-degree bend. But when it comes to a slab designing, this is where the bends are going to be there. So this is going to be the hypotenuse. So you will be taking the hypotenuse value, considering first length in the first level, and then you will be adding up, you will be summing up with the hypotenuse and then the remaining length of the bar. So this is where you will get the complete length of that particular bar length. So this is the bend length with respect to slab, and this is the bend length with respect to corner bends. That is whole what it comes as the bend lengths. And then moving forward, we have for overlapping or the lap length. What exactly I meant by this overlapping is, now when there is a higher column that is required, like I mentioned, if it is a 15-meter column that is required, and the standard of any bar, you know, it is for 12 meters. An extra 3 meters is required. So that particular overlapping would be happening. Overlapping is nothing but this is a bar and this is another bar. So when you are actually keeping it up based on what is the length of the second bar as well as the first bar, how much amount of weight will be acting on this and this particular bar will be studied. So the amount of stress and strain that this particular bar will be going, it will be designed properly, and then based on that particular design, the overlapping, the distance also matters. So this is where the overlapping comes into this picture. And this definitely happens with respect to the clubbing of all of these rebars. This is the whole overlap length or the lap length that I can actually tell. Now, in this ladder kind of image, I'll just show you the technicalities of it. Now, these were the hooks. This is one of the bend and this is another bend was what I meant. So that is why it is called as hook, and there are 2 in numbers. The bends are of 5 in numbers. So over here, I'm sure you would have got a certain amount of clarity. Now, in this ladder kind of image, This is actually a cross-sectional image of a column, of a reinforced column. Now you can see over here, this is a 3-meter bar that they have taken. Now, this is one of the main bars. This particular symbol shows what is the diameter of the main bar. So the diameter of this particular main bar from this top angle, this is going to be 16 mm. And then these are longitudinal bars. The longitudinal bars are the horizontal ones. That is nothing but it is called as the stirrups, and they have a diameter of about 8 mm. So these are the technicalities of the rebars. And then over here there is the overlapping joint. So this is for the upper floors, and this is to the neck column, or that will be joining with the footing. So with the footing, what happens once the foundation level is completely done, you would have seen those extra extensions with respect to the bars. That's where the overlapping of the other floor bars comes into the picture, and when the remaining opening is been there for further construction purposes on most of the terrace, you would have seen that's where this overlapping for the upper floors happen, and then the construction of that particular structure continues. So by this, we are coming to the end of basics of bar bending schedule that is required over here. So by now, I am assuming you will have a lot of clarity with respect to how BBS started, what exactly a BBS is, what exactly a bar bending schedule is, basic things of the rebars that you will have to be considering, that is happening to be the length, weight, as well as the density, and a few technical terms regarding what a hook length, what a bend length, as well as these overlap lengths are. These are few technical terms you will have to basically keep in mind before you enter into becoming a site manager who will be handling all of these BBS related works. So by this, we will be ending up this segment with respect to the bar bending schedule. In the next session, we will be talking about the concreting, and followed by we will be having more talks on the interior works in details. So till then, thank you so much.